Get all day 12.
Hey guys and gals, parents, students, how you doing? How are you doing this fine day? Appreciate you hitting that play button as always. I love it. I love it. I love it. You know I love it. You beautiful, intelligent, wanting to learn peoples. Let's go. Quickly, guys, I'm my own mod here, so I have to kind of check, make sure everything's good on the stream. Oh, sounds like it is golden, golden like Freddy. Let's go. All right, so perfect. How you doing? Welcome, welcome. Welcome to this Unit 5 series, Geometry, Shapes, and all those sort of things. Guys and gals, because you love shapes, right? Don't ya? Triangles and squares and rectangles and all those sort of shapes. And we're getting into 3D land. Let's go. Supporting you parents here on the channel. Those of you that are, quite possibly have made the decision to homeschool your child or your children, here to support, here to help. I imagine you have lots on your plate, so if I could help, I am willing to help. Now, just to let you guys and gals know, parents, I'm planning on staying on topic, okay? The goal is to teach mathematics and mathematics only. Okay? I may get sidetracked a little bit with some whatever stories or whatever, try to create some humor and laughter, but that's about it to the extent. For the most part, over here, we are teaching. Let's go! Students, you're also welcome. Welcome to be here as well. You might be going to a public school or whichever, maybe a private, I don't know. It's none of my business anyways. But if you're on YouTube searching and you're looking for extra support, extra help, I'm here to help. Trying to do kind of a grade 9, 10, 11 curriculum sort of thing. I'm going to try to make this quick, but here to help you students. You might have a teacher, instructor that isn't maybe teaching, which I really don't want to get into because, that's not cool. Or maybe they're just not good at teaching, and that's why you're searching the internet for extra additional support, because you want to actually get good grades. And man, you are awesome. I love that thinking. Man, I'm telling you. It's beautiful. It's beautiful that you're taking the initiative, right? I love that. That's leadership. That's drive. That's a good quality. So good for you. Keep that up. All right. So let's get into it. We're doing geometry. I love geometry. It's fun. So this video is going to be doing some definitions. I know, guys, I know it's the boring stuff. But we have to talk a little bit about what is what and what is what, right? You need a kind of an idea. So that way, when you're solving problems, you understand the terminology as well and the questions. So let's get into this. We're going to begin with a line. Real basic stuff. Okay, what is a line? Most of you are like, yeah, I know what a line is. I just drew one on my piece of paper. But so I'm gonna research on the internet. Okay, I'm not gonna do a lot of snipping tools and whatever. If I find anything that is useful, I'll probably snipping tool it, and then just kind of bring it up and share it with you. There we go. So what is a line? Here it says it's an infinite, unbounded set of coplanar points that form, little technical, some of the jargon, I guess, for a line. But okay, what else can we find? Is there anything that's a little more basic? Not so, let's just try to keep it generalized, That's what we're going for. Okay, so a line, a set of connected points in a straight path that continue forever in opposite directions. They do. A line has one dimension length. Okay. I don't really think it's... Yeah, that's true. You have 2D, which is X and Y, horizontal, vertical. And we're basically a line is a one-dimensional length. Yeah, that makes sense, for sure. A line does not have a width or a height. True, I guess. If you draw it on a piece of paper, it can have thickness or whatever, but for the most part, they're just trying to say, yeah, it doesn't have width or height. So what they really mean is it doesn't turn into like a shape like a rectangle or a square. It's pretty much just, a uniform line, right? With uniform thickness. We use either one lowercase letter to name a line or 2 points with the symbol. So when they name a line, right, this is a point A, point B, or they'll put this, and basically it means line segment AB. Okay, let's continue. Line segment. We just talked about that. What is a ray? Okay, what is that? What is a ray? So I'm searching. Maybe you want to look for the definition as well, guys. I just type in, whoops. Here, let me just click back here. See if I can, there we go, hit that. Go all, see what kind of other general line definition they have. In geometry, a straight line, usually abbreviated line, is an infinitely long object with no width, depth, or curvature. A line is a one-dimensional figure which has length but no width. Okay, it's made of a set of points which is extended in opposite directions infinitely. It is determined by 2 points in a two-dimensional plane. Okay, we're going to stop on that, so let's continue. So we talked about line, we talked briefly about line segment. What is a ray? What is a ray? In geometry. Definition of a ray in geometry. Okay. Let's see. We'll just, I don't know, maybe this will work. Let's see, new. And there, I'm just going to bring this up. Ray, a part of a line that has one endpoint and goes on infinitely in only one direction. Okay? A ray is named using its endpoint first and then any other point on the ray. So BA. I guess really it probably doesn't matter if it says AB or BA. Okay, so there's that. Let's see what else. See what else we can bring up here. Okay, part of a line with a starting point but no end point. Array continues on forever, only in only one direction. We use the starting point and a second point on the array to name it with the symbol, the arrow symbol, right? So yeah, that makes sense. That's array symbol. You're going one direction. Okay, let's continue. Angle. What is an angle? Actually, briefly, we should quickly talk about what is geometry. Okay, here we go. Here seems to be a really good definition of geometry. Really what we're working on is geometry, so maybe we should talk about it. Okay, I'm just snipping tool, but I'm not saving these. I'm just closing up. Okay, what is geometry? Geometry is a branch of mathematics that studies the shapes, sizes, positions, and properties of space. As you can see, a plane would be this front surface of the, we'll just call it a cube or whatever. So that would be a 2D, right? X, Y. So this is a plane, a flat surface. And then here we got another plane going in a third dimension. So essentially we have a three-dimensional object. Okay? Geometry is essential in solving spatial problems and is widely applied in various areas such as architecture, engineering, design, physics, astronomy, and more. Additionally, it plays a fundamental role in understanding the nature and structure of the universe, as well as in the development of advanced technologies and the creation of artistic works. I love it. I love learning because you get to learn more about the world, guys and gals. So learning is awesome. It truly is. Okay, I'm gonna close that. So that, and let's see, what else do I have for a definition? What is geometry in maths? I don't know why it's plural for some reason. That I don't understand. But anyways, in simple words, geometry is defined as a branch of mathematics that deals with measurement, properties, and relationships of points, lines, angles, surfaces, and solids. Put even more simply, geometry is a type of math that deals with points. We just kind of said that, but there you go. Okay, let's continue because I want to kind of push through these definitions, and this is kind of I think the best way to do it. I'll give you guys and gals some visuals as well. All right, let me just click back here. Okay, what is an angle in geometry? Okay, images. Let's go here. Okay, this kind of is a good one, I guess. The source is going to be Q math. Okay. I guess I should mention the sources. Parts of an angle. Here we go. An angle basically rotates. I go with the concept of counterclockwise. So imagine this line here was initially flat and it just kind of rotated up. So this is the rotation angle. This is the pivot point or vertex. Base arm, I guess you could call this. This could be technically X. And of course we have points on the line as well. And then the arm, I guess, would be, the actual line segment that is rotating. What other images could we use? So we got a bunch of other ones here which are kind of good, but we just want to see an angle. Okay. And let's see what else I can find. No, I don't want to use that. I want to keep the images kind of just basic, general. What is this? Okay, I'll just do this one quick. Okay, and then we have different types of angles, which we'll probably be talking about. I can't really zoom that any bigger for you guys and gals, sorry. Acute angle, so an acute angle is less than 90 degrees. Right angle, an angle that is exactly 90 degrees. Obtuse angle, it's greater than 90 degrees, but less than 180. 180 is flat. Here we go, you can see it here. An angle that is exactly 180 degrees, so basically this is the pivot point. Rotates 180 degrees and stops flat, right? So they call this a straight angle as well. Reflex angle. Reflexes are either in what I've been talking about in the past. I'll do a diagram for you guys again, just so you understand. You follow along, you'll know what I'm talking about. But there's quadrant 3, quadrant 4, so a reflex angle could be in either of those quadrants. Anywhere between the 180 and the 360, essentially. So an angle that is greater than 180 and less than 360. And then you got a full angle, which basically is the full rotation. Okay, we'll close that. We kind of went over a bunch of stuff here. What is a protractor? I'm trying to get through this quick in math, right? So you'll get a compass set or whatever. Here we go. This one will work. Snipping tool. Right, most of you already know what it is, but it's an instrument that you'll get with your compass set that you can use to measure angles. Again, I always measure angles from the right to the left, so counterclockwise. Some people might measure this way. It just depends on what kind of angle you have. But you might as well get used to this being horizontal X, 90 degrees is Y, and you have a line segment that pivots about this point here and rotates however many degrees, okay? So we kind of went over these quickly. I'll see if I could find, I do have my diagram as well. I could try to find, let's see, let me move that. That is in pictures. I moved my stuff, so okay, but I got it. I found it. Where is that? Right here. Okay, here we go. Okay, of course these are triangles, but if we're talking about angles, a right angle is 90 degrees. These two line segments here, just ignore this line. This is just a line that's completing or the intersecting, so that it completes the shape of a triangle, obviously. But we're going to focus on these two lines. So this would be our horizontal, and this would be an angle that's rotates about this point up, but it's less than 90 degrees. So it's acute angle and it's handsome and beautiful at the same time. And then you got an obtuse, which is greater than 90 degrees. So it rotated about this point, going this direction, past 90 degrees, right? This is 90 degrees. Okay. Let's see if I have something else I could share that might, just to make something a little bit visually better for you. We'll just kind of go do this one here. Random websites I'm just doing screenshots from. Splash learn. Acute angle, again, less than 90 degrees. A right angle, perfect 90 degrees. Obtuse, right? that is the same as this. Yeah, obtuse greater than 90. And then straight, and then reflex. Well, the reflex is the way it's drawn really isn't accurate, but if I drew it, a reflex would be, so if I go like this and like this, I probably shouldn't do it so quick. We'll go like this. I'm just gonna draw, whoops. My bad if it's not perfect. So this is just our X and Y here. This is positive. This is Y. It's also positive. Okay, so like I've been saying, this would be our vertices, our rotate points. So our origin, it's typically called, we have two intersecting lines here, okay? And these are 90 degrees, right? So we have a horizontal line and a vertical line. And the origin is, coordinates are 0, 0. Okay, so basically that means X, Y. I haven't really explained that, but X is 0, Y is 0 at this intersection. Okay, because we technically can go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Going positive, right? Same thing with negative. -1, -2, -3, right? We'll go over the integer grid in the future. Okay, so remember the definition of a reflex angle, right? A straight would be here. This would be 180 degrees. This is 90 degrees. This is 0 degrees. Or 360. Like technically speaking, if we rotate, I'm just going to draw our line here. That's good enough. Okay, rotates counterclockwise. Okay, and I call this quadrant 1. This is common, guys. Quadrant 2. Quadrant 3. Again, it's counterclockwise, right? Counterclockwise. Roman numerals here we're using. And 4. Okay, so a reflex is between 180 and 360. If we go the full rotation, back to 360. Okay, 0 and 360 are technically the same position, right? That's one rotation, one singular rotation. Okay, going back. So here they got 240, right? So we essentially, now this isn't really accurate, but 240 is 180. I'm just going to subtract here so we have an idea. 0, I have to borrow 14, 8 and 8 is 16, so 60 degrees. So this would be 60 degrees in here. 180 plus 60. So the angle's exaggerated, but we'll go over how you figure out angles here a little more, okay? So that's a reflex. It could be either in this quadrant or this quadrant, okay? All right, let's continue. And then a complete one, right? So again, just like we were talking about, full rotation, it would be a complete. Okay, let's get rid of that. Back to here. So we've talked about most of them. We've talked about straight, reflex, bisect and angle. Stuff really I haven't really gone over much myself. Let's see. I'm just gonna write bisect an angle in geometry. Bisector of an angle, that'd be probably the same thing. In geometry, an angle bisector is a line or ray that divides an angle in two congruent equal angles. Okay, so I'll bring up an image here. Okay, so I'll just so that you guys have something visually, right? Kind of helps. Q math again for the source. Okay, OC is the angle bisector of angle AOB. The way they do these, just so you guys understand what this means, angle AOB is AOB. So basically this line and this line, okay? And OC, well, I don't know, it should be a line segment. That's a ray, right? That would be a ray. Ray OC is the angle bisector of this. So basically it splits this in half. So this total angle, you divide it by 2, you have these two interior angles, essentially. It's pretty easy, right? So there you go. What other definitions? This means the angle is split exactly in half. An angle only has one bisector. Okay. Again, when you guys, if you want to search the terminology, I just type, I don't know if you're using Google or whatever you use for your searches. You would obviously have a different browser or whatever, but either way, I just type bisector of an angle in geometry. An angle bisector, or the bisector of an angle, is a ray that divides an angle into two equal parts. Okay, there. So that's how you bisect an angle. Okay, adjacent angles. Adjacent angles in geometry. I don't really have anything other than this for visuals for you guys, okay? Adjacent angles are two angles that share a common vertex. Okay, so let's see if we can find something here that's going to work. Two non-overlapping angles that share a common side and a common vertex. Angle A, angle B are adjacent angles, okay? Essentially, it's kind of what we already looked at. Right, it's kind of like bisecting, but I don't know if the angles are the same. Right? Angle A and angle B are adjacent angles. They're beside each other. That's what adjacent means, okay? They're next to each other, and they're pretty much shoulder to shoulder, if you want to look at it that way. That's it. That's the meaning of adjacent. And they're non-overlapping, okay? And they share a common side and a common vertex. Okay? Like we could even, like something like this as well would work. Just to give you another visual, Q math with a visual. Okay, adjacent angles. Again, they don't have to be, right? They're different angles. This angle 1 is greater than angle 2. Okay, common side. But they're still adjacent angles. Angle 2 is adjacent to angle 1. Okay? All right, let's go. Complementary. I know we got to go over all these definitions. It's just kind of part of it. Okay, guys? Here we go. This is going to work better for a visual. Media for math, okay, is the source. Complementary angles, angles whose measures add up to 90 degrees. When adjacent, the angles form a right triangle. Okay, all right. So the key thing, I guess, to remember is both of them added together form a 90-degree angle. Okay, now I'll see if I can find a definition here. Come on. Oh, I'm on the wrong one. There we go. Okay. So when the sum of two angles is 90 degrees, then the angles are known as complementary angles. Okay, so remember that, guys and gals. Complementary, 90 degrees. You might have to do little tricks, memory tricks and stuff, whatever you want to use to try to remember, right? You want to kind of correlate the terminology together. Complementary, 90 degrees. You don't really need, all you need to know in the back of your mind that there are two angles together. This is angle 1, this is angle 2. Together, you add them both together, they add to 90 degrees. So all you really need to remember, complementary, 90 degrees. Okay, supplementary. Supple. It's been a minute since I've been over this kind of terminology. So, mentary. Supplementary angles in geometry. Supplementary angles are any two angles whose measures sum to 180. There you go. Okay, so now complementary 90, supplementary 180. Okay, here we go. I'll give you a nice visual. Source, Brighterly. Okay, just something quick. Angle, you could call this angle theta, angle beta, or you could call it angle 1, angle 2, whatever you want to call it. But again, it's just one angle plus another angle. There's only two angles, right? One's 50 degrees, the other's 130 degrees. Together they add, they create a straight line essentially. But anyways, they add up to a straight line. Supplementary, 180. Complementary, 90. Supplementary, 180. Okay? And when you're doing your exam, I just recommend you write down quick notes. You can write comp, 90 degrees. Supple, 180 degrees. Right? And then when you come across that part of the exam, you'll smash that answer really quick and you can carry on. Right? Again, you probably, realistically, guys, when you're doing exams, you probably have 2 minutes per question. If you can smash a question in like 10 seconds, you save so much time. So you can balance it and maybe take an extra minute on another problem, right? Again, 2 minutes is probably average time you should be spending on a question, okay? I know it doesn't sound like a lot of time, but again, if you smash some questions in 10 seconds, that gives you more time for another one, right? All right, let's continue. Congruent. Definition of a congruent angle in geometry. Okay. I want to find something that isn't too... Okay, that's corresponding. Where's congruent here? Here we go. Media for math again. With a nice visual. Now, I'm not recommending you go check out the website or whatever. I mean, it's okay if you do, but I also want you to come back and watch the content here as well. Okay, guys? So I appreciate you. All right, congruent angles. Two angles that have the same angle measure. Congruent. So basically it's saying, well, if we just talk about the angle and not the triangle, so the angle is CAB, right? We're not even talking about CB. This is line segment CB, right? That's not even included. What they're showing here is angle CAB. That's what it means. It's congruent, approximately congruent, I guess. Approximately usually is that squiggly or tilde sign. Equal to FDE. FDE. So that means that this interior angle is exactly the same as this interior angle. Two angles that have the same angle measure. Okay? Congruent. Okay? And that was a good definition right there. Or a visual for you. Whoops. What am I doing here? I'm trying. Whoops. Goodness gracious. Definition. Congruent angles are two or more angles that have the same measure. Okay? In simple words, they have the same number of degrees. Okay? That's all you need to remember. Opposite angles. Definition of opposite angles in geometry. Okay. Opposite angles are the two angles opposite each other when two lines cross. Okay. Let's see if I can find a nice visual here. This might work. Okay. Hold up. Yeah, this looks like a better visual. I want to try to keep it pretty basic, the visuals. Worksheets Planet with this visual. What is an opposite angle? Obviously 70 degrees is opposite 70 degrees. They're opposite, right? An opposite angle, also known as a vertical angle, okay, just think of it as an opposite, is formed when two lines intersect. As you can see, we have, we could call this line segment AB, line segment CD, right? They intersect each other. So again, we have two lines, so all you need to really remember is if this angle is 110 degrees, that means the opposite angle is exactly the same. And it's the same case as this as well. Okay? Opposite angles are always congruent. Okay? We went over that congruent definition already. Congruent. Congruent angles are two or more angles that are identical to each other. Okay? Congruent. And they're also opposite each other. Opposite angles are always congruent, meaning they have the same measure in geometry. They play a crucial role in various theorems and proofs. So really, that's just all you have to remember is this, right? If you're given this angle and this is unknown, this is why this is explained, guys. Automatically you go, oh, I have 70 degrees here. Oh, that means this one's 70 degrees as well, right? Understanding opposite angles is fundamental to exploring the relationships between intersecting lines and angles and geometric properties, providing insights into the symmetry and balance of geometric figures and shapes. Okay? Whoops. Let's see, do I have anything else that may help? Let me just click here. They can also be called vertical. I don't really like that terminology, but whatever. Opposite angles have the same measure, making them congruent. Okay, just correlate in your mind. Opposite angles are congruent to each other. Okay, let's see if I can give you another visual. No, not that one. Something like this. This would be kind of good. By math doubts. Okay, so this is better because it's a little bit more, obvious, right? This angle is opposite this angle. This angle is opposite this angle. They're both congruent. These two are congruent. Okay? Perfect. All right. Perpendicular lines. Perpendicular lines in geometry. Whoops. Okay. Okay. Media for math. Okay. I'm going to try to be consistent with some of the sources I'm using here. Okay. Oh, goodness gracious, Sally on Sundays. Okay, here we go. Perpendicular lines. Two coplanar lines that intersect at right angles. Okay, essentially it's kind of like the little graph I've been drawing here, right? This line and this line they're perpendicular to each other. Okay, going back here. In coordinate geometry, the graphs of two linear functions with slope. I don't want to get into that. We're going to eventually talk about that kind of stuff. But all you need to remember is QMath will be another example. We're just going to keep it real simple. Okay? KISS method. Keep it simple, Stanley. All right? I'm not saving these because it's just bits and bytes on my computer. Perpendicular lines, right? So we have line segment AB and we have line segment CD. Together they create, this symbol here is the perpendicular symbol, okay? 90 degrees is what this means, okay? Anytime you see this little symbol, that means it's a 90-degree angle, okay? Remember that, all right, guys? All right, definition. Perpendicular lines are two straight lines that meet or intersect at 90 degrees. The opposite of perpendicular lines are parallel lines, which we're going to be kind of talking about, I think, now. Yes, we are. So, parallel lines. Parallel lines don't intersect, okay? They run parallel with each other. Okay, parallel lines are those lines that are always the same distance apart and that never meet. They never cross, they never intersect. Okay. Here we go. QMath is perfect. Because we want to keep the visual simple, right? Without over confusing it. Okay, simple. So we have parallel, this A and B, they're parallel to each other. And the distance that they were talking about, if you measured this distance, right, you could actually measure it. It's consistent throughout. You can measure here, you can measure here, the value is going to be exactly the same. Okay, and it doesn't matter if they're rotated at an angle. Again, this would be going back to up here, what was it, line segment? They're not rays, right? A ray starts at a point, so at a line segment. This is a line segment, this is a line segment. They're parallel to each other. Okay, and definition, parallel lines are those lines that are always the same distance apart and that never meet, okay? Parallel lines are two or more lines that are always the same distance apart and never intersect, even if they are extended infinitely in both directions. They are always equidistant. Equidistant means equal. Just think equal. Equidistant. And distant. Now, if I draw two parallel lines, they're not going to be perfect, guys. I can't really snap a straight line. It's not like AutoCAD, right? I wish I could. I could just draw a straight line, right? These would be parallel, right? It's not perfect. Just assume they're perfectly straight lines. Again, if you measured this distance, let's say it was 5, right? Equidistant. They are always equidistant and run in the same direction, right? Okay, which means they have the same slope. Yeah. So this would be like a zero slope, I guess. But if you rotated, they would have slope. Yeah. We'll talk about slope in the future. We will. Okay. Going back down. Hopefully we're almost done here. Yeah, just about done. Let's see. Parallel transversal. What does that mean? What is transversal in geometry? Transversal line, I guess. Transversal is a line that passes through two lines in the same plane. Oh, okay. Here we go. Okay, so Math Planet. This is a really simple diagram. Whoops, I gotta close this. Again, I want to just snipping tool a really simple generic line, right? I can't zoom it, but there we go. So we have two parallel lines, and this is the transversal line. Okay, the transversal line, if you see, creates these congruent angles. Okay, that's why we're talking about this. This angle is the same as this angle. This angle is the same as this angle. They're congruent. Same thing with here. All the way up, same thing. They're exactly the same thing. This angle is even the same as this angle. This angle is the same as this angle. Right? All you need to do is remember that, right? I mean, I could give you some other images, I guess. Let's see if this will work. Corresponding angles. Whoops, cancel. I don't want to save it. Right? Again, just like I was saying, right? This angle is the same as that angle, right? All you have to realize is, hey, wow. Right? Because you'll be given this angle, and they might want you to solve. They might ask you what angle B is, right? All you need to say to yourself, oh yeah, this angle is the same as that angle. Really, it's that simple. Oh, this angle is the same as this angle. Oh, this angle is the same as this angle. Corresponding angles. Okay? And there we go. We just talked about corresponding angles right there. So all you have to remember is, transversal. The singular line is a transversal line. These are our parallel lines, right? Again, it's all the same thing. This angle is the same as this angle. This angle is the same as this angle. This angle is the same as this angle, right? It's hard to tell. That's a vertical line, it looks like, but it still works out the same. Okay, guys, gals? All right, let's finish this up. Alternate interior angles. We kind of already talked about that a little bit, right? Alternate is like the opposite, right? What we just talked about. Alternate. I just think opposite. Um, what does this say? Oh, okay. Here's a nice little. Let's see if I can bring this up. Oh, that's pretty small. I wish I could. Can I save the image? Where am I going to save it? We'll see if I could actually zoom this up. Give me a sec. And what's the source? Okay. Let's see. Give me a sec, guys and gals. Trying to hurry here. Looking for. Okay, yeah, this will work. And I'm gonna call it. Oh, goodness gracious. Oh well, looks like I'm gonna have to. Let's just go like this because I don't feel like trying to type that. I have to try. Whoops. Save image again. I gotta start again here, guys. I'm trying to hurry. And here, and here, and here, and here. Almost there. Okay, and I'll just put a dash there. That should work. And I'm just gonna go like this and see if I could actually open it. So open, cancel. There we go. We kind of lose some of the detail on it. Sorry, guys. I tried. Such a small image that I really can't, you know. Bummer. What about this one? Trying to find something that'll give us a. I'll try to have to look for something in the future. Way too small. Let me just. Whoops. No. Open. Cancel. Close. Alternate interior angles. Yeah, it's kind of hard to read. Alternate exterior angles. Yeah, I'm sorry, guys. That's kind of a brutal image. Brutal. Let's see if we can find something that's gonna work. Ooh, this might work. Snipping tool. Let's do this. Okay, two angles are corresponding angles when they have corresponding positions. Two angles are alternate interior angles when they lie between the two lines and on opposite sides of the transversal. Again, this is the transversal, right? If I actually save that, I would be able to zoom that up too. Let's see if I can save this. I'm just going to overwrite it with that other one. Come on. Where did I put you? Where'd you go? Where are you? Oh, it's a JPEG, that's why. Okay. Why does everything have to be... is that the same folder? Yeah, good enough. Okay. Parallel. I'm just gonna... Oh, goodness gracious. I apologize, guys. I'm trying to get something decent for you, okay? But it's not like I could just... I'm just gonna go like this. I'm just going to save that like that. Okay, this is going to have to do parallel and perpendicular lines. Okay, good enough. All right. Okay, so now I'm going to see if I can actually open that. Is it here? I need to delete that other one that's trash. I'll have to look for it after. Yeah, it's this one here. Delete. Thank you for your patience, guys and gals. Okay, here we go. There we go. That's better. I want to be able to zoom in and stuff so you can see it better. Okay, so like here we go. Two angles are corresponding angles when they have corresponding. What the Batman? This commercial I got to deal with. Just a sec. And I don't really. No, that's a big pass. Big pass. I need some coffee here quickly. I'm going to try to finish up here, guys. Okay. Going back to here. I'm just going to kind of, instead of talking about it, you could come back to the video and reflect on it. Just ignore all this stuff here. Don't let that confuse you. We're not getting into that right now. Okay? Don't just ignore it. Right here, let's just talk about this, what it says. Okay? Basically, this is the slope of a line formula. Essentially, with that's what that is. Okay, but you don't need to worry about that. We'll talk about that in the future. Okay, and then there we go. Okay, just to speed things up, right? And we talked about a bunch of stuff. What is a polygon? Okay, what is a polygon? A polygon, because we're going to be getting into that a little bit. And then you have congruent polygons as well. Types of polygons. Here we go. A lot of you guys and gals probably already know this already. Okay, I want to do this definitions in one video. It's kind of the idea here. The idea here. So, of course, you have your typical triangle, quadrilateral. I guess a square is called that. You have a pentagon. You also have a hexagon. Hex is 6, right? 1, 2, 3, 4, 5, 6. Heptagon, we don't really talk about that one much, but octa is 8. If you think octopus, octagon. And then we have nonagon and decagon. You can search that up anytime you like. What does it say? In geometry, a polygon is a flat, right? A 2D plane. Think flat. A flat plane, a flat surface is also called a plane. Plane. A polygon is a flat, two-dimensional closed shape bounded by straight sides. It's essentially a shape formed by connecting straight line segments, edges, to create a closed path, right? It's a closed shape. Okay, guys? Here we go. Snipping tool again. Media math for the visual. Regular polygon, a polygon with congruent sides and a congruent interior angles. Okay, congruent sides, congruent. So that's an equilateral essentially. equilateral, square, regular polygon, and regular hexagon. So these are examples of regular polygons. Okay, things you really don't pay much attention to, but we don't really talk about it very much, right? We just call them squares and what else not, right? Polygon in geometry, any closed curve consisting of a set of line segments, sides connecting such that no two segments cross. Okay? The simplest polygons are triangles, 3 sides, quadrilaterals, 4 sides, and pentagons, 5 sides. Okay? And then we have... Okay, so what is a regular polygon? Of course, I could show you a bunch of other different shapes here, right? Math monks for the source here. Again, this video should be great for you guys to reflect. If you kind of forget, you can reflect back on the video, and here you go. Okay? All polygons, okay? Again, the definition, what are regular polygons? If all the sides and interior angles of the polygons are equal, they are known as regular polygons, right? So these would be equal. Obviously, these are equal, right? These are all equal, the interior angles, okay? They are known as regular polygons. The examples of regular polygons: square, rhombus. A rhombus is, let me just undo most of this here. If I recall, whoops. I want to save that. Yeah, whoops. I'm going to try to draw it. I'm trying to be fast though. Okay, so this is kind of rhombus. Now these lines are going to be the exact same length, but essentially you have, you know, it's kind of like you had a rectangular toy and grandma ran over it. Okay, rhombus, rhombus, rhombus. Okay, the H is silent. All right, are we almost done here? Similar polygons, kind of what we already talked about. Regular or similar polygons, right? And I'll confirm that. What are similar polygons? There really is no similar. Okay, here we go. I got it. A pair of polygons. In geometry, similar polygons are polygons that have the same shape but not necessarily the same size. Okay? Here we go. Okay, yeah, this is cool. Oops, I keep doing that. I gotta close that stuff. Hopefully this is gonna be big enough. Okay, there's the source right there. Same shape, but it's kind of like it's scaled up, right? But they're gonna have the exact same angles. The angles are gonna be exactly the same. It's just scaled up, really. Okay. Similar polygons are polygons that have the same shape but not necessarily the same size. They are characterized by having corresponding angles that are congruent, equal in measure, and corresponding sides that are proportional. It's kind of like scaling something up, essentially. The same could be said with triangles too, right? Just to give you some other examples. Okay? Right? They have the exact same angles, but it's kind of like scaling it up, right? Proportionately and uniformly. So you could actually use like ratio proportion to figure out sides, right? Let's see if I can find something else for you. I don't want to have a bunch of numbers and stuff. You might see symbols like this. Okay, so what I'm talking about is, right, so they have a single curve here. That means this angle is exactly the same as this angle. You have double lines, that means this angle is the same as this angle. And here's a triple line. This angle is the same as that angle. That's what that means, okay? So all the interior angles are the same, but it's just, again, just scaled up. That's all it is, okay? That's it. I'm going to leave it at that, guys and gals. Okay, I think that's lots of information. We covered a lot. Again, you can reflect back on this video if you need to kind of go over the definitions again. I'm Johnny Whiskey Tango Sharp. I'm doing a lot over here for you guys and gals. Yeah, so stay tuned. I just have a bunch of thoughts in my head. Like, I'm obviously doing the Unity and all that stuff as well, but my main focus right now is the mathematics for you guys and gals. I think the world and you guys kind of need more of that support right now. This is for you parents, homeschooling your children, any students that are looking for additional support and help. Again, my name's Johnny, and I'm going to leave it at that. I'll talk a little bit more in the next video. So thank you for watching. Have a great rest of your day, and take care for now. Peace out.